Alright, some more example problems. If I have 250 milliliter bag at a temperature of 19 degrees Celsius and I leave it in my car, which has a temperature of 60 degrees Celsius, what will the new volume of the bag be, assuming that the bag gets to the same temperature as my car? So, let's go ahead and do what's first, and that is P1 V1 over N1 T1 equals P2 V2 over N2 T2. Okay? So, next I want to write down my variables, what I'm given. So let's take a look at what we have in the problem. We have 250 milliliters of a volume. So we have a volume in there, we have a temperature. Let's see, we have another temperature, and looks like I want to know a new volume. So we're looking at volume and temperature, and that means since no pressure nor number of molecules was mentioned, I can cancel those out because I don't need them. Okay, which means I can rewrite this equation as V1, or for the equation for this problem, V1 over T1 equals V2 over T2. And then, like I say, you want to cross multiply. It makes it a little easier to get rid of your variables. So you'll have V1 T2 equals or I should say V2 over or times T1. So now let's assign what's T1 and what's T2 and all that kind of fun stuff. So let's look first. We have 250 milliliter beaker bag at temperature at 19 degrees Celsius. So my volume, my initial volume, or my first volume, is 250 milliliters. Now, this is a problem that, your answer is in milliliters, or your volume is in milliliters, and I want to know a new volume, but I didn't specify the unit that I want your volume in. And since I didn't do that, you can have your volume, when you're all said and done, be in milliliters. That's fine. Or if you want to just feel comfortable and just always convert everything to liters, you can. But understand that if I don't specifically say I want this new volume in liters, or I want this new volume in cubic centimeters, then you don't need to do any conversion to get it to where you need to be. So I know my V2 will be X in milliliters. My temperature 1, which is 19 degrees Celsius, okay, and then my temperature is my T2 is 60 degrees Celsius. Okay, like I said though, always convert temperature units from Celsius to Kelvin, okay, which would be just adding 273. And so for both of these cases, I need to add 273 to 19 and then 273 to 60. And those amounts would be 292 Kelvin and 333 Kelvin. So now that I have my values, let's go ahead and plug in the problem. So let's go ahead and put this right here. V1 is 250 milliliters. Remember, always have your units in there. In fact, I'm going to make this arrow a little smaller. 250 milliliters. I'm going to times that by T2, which is 333 Kelvin. I'll make that equal to V2, which is my variable, X, and my T1, which is times 292 Kelvin. I will then get X by itself and divide both sides by 292 Kelvin. Alright, make sure that you cancel out your units, or pretty much cancel out anything you can cancel out. On the left side of the equal sign, I can cancel out the Kelvin, but I can't cancel out the milliliters, which that's good because I want my answer to be in milliliters. Okay, and then on the right side, I can actually cancel out the 292 to get rid of it. So now I have X equals 250 milliliters times 333 divided by 292. And do that math. Doing the math, my answer comes out to be 290 milliliters. Now, if you did this problem, you probably came out with 285.103. But remember, we need to pay attention to sig figs, and this number right here only has 2. Okay, so if it only has 2, that means my answer must only have 2. Okay, so let's go ahead and take a look at another. Remember, if at any point in some of these problems you're writing these down, you don't understand where these numbers are coming from, you can either leave a comment or just ask me in class. So, next one. Okay, how hot will a 3-liter balloon have to get to expand to a volume of 7 liters and I assume that the initial temperature of the balloon is 15 degrees Celsius. Okay, so I want to know what temperature looks like. Okay, so regardless of what I think I know, I want to do what I know I should be doing, which is write out my equation, which is P1V1 over N1T1 equals P2V2 over N2T2. Okay, and then need to look at what I'm trying to find. I'm trying to find, hot. That's probably a temperature importance. And looks like I have temperature. And then I look through, I have a volume. And then looks like I have another volume. So I have a temperature here. I have a volume there. I have a volume here. And then I'm going to have, I have a temperature here. And actually tells me it's my initial temperature. So I have a temperature here. So I'm going to have TV, 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 TV. Too much TV. So 1, 1, 2, 2. Now, because these are the variables that I have, I can make the assumption that all the other variables are constant. So number of moles and pressure are gone. Don't need to worry about them. They are constant. They did not change. So I can rewrite this equation, V1 over T1 equals V2 over T2. Like I said, cross multiply just the variables, okay, just so you can, and then you can plug in the numbers later, okay, but you'd have V1 times T2 equals T1, I'll just keep the same variables in the same order, V2 times T1. So, doing that, let's go ahead and plug in our numbers first. So I want to know, looking at the problem, so looking here, my initial temperature is 15 degrees Celsius. My initial volume looks to be, let's see, I'm going to expand to a volume of 7, so it must be at 3 liters. And then I have a volume of 7 liters that I'm getting 2. And then my temperature, the second temperature, is what I want to know. Okay, so plug them in. But of course, don't forget, we need to convert that to Kelvin. So 273 Kelvin, 273 plus 15 is 288 Kelvin. And we want our answer to be in Kelvin. So now here's the thing. If I do ever ask you, hey, how hot will it be, or what's the temperature in Celsius, make sure you subtract the 273 so you'll get the appropriate answer. So let's go ahead and plug them in. Okay, so we have V1, which is 3 liters. Okay, 3 liters. And multiply that by T2, which is my X. And I'm going to equal that to V2, which is 7 liters. Okay, and I multiply that by 288 Kelvin. So obviously, if you can tell, these numbers are a little different. We're going to have a very few amount of sig figs. So first thing I need to do is divide both sides by 3 liters. So I divide this by 3 liters. I divide this side by 3 liters. And then my 3 liters will cancel out here, and my liters cancel out there. So X will be 7 times 288 Kelvin over 3. Do that math real quick. So we have 288 times 7 equals... Okay, now here's the thing. Don't forget, when you're doing these equations, make sure that you maintain your sig figs every step of the way. So this number right here, 7 times 288, is actually going to be 2016, but you need one sig fig because there's a 7 there. So it's really 2,000. Okay, so 2,000 divided by 3 is going to be a very unhappy number for those very religious folk. Would be 666.66666666. However, we're only going to have one sig fig, and so 666.6 repeating with the number of sig figs, I would just round that to 700 Kelvin. Okay? Now, I mentioned earlier, well, what if I wanted the answer in Celsius? You would just take 300, so you would take 700 Kelvin, and you would take away 273, okay? So 700 minus 273, so 700 minus 273, and that's going to give you your answer in Celsius, which is 427 degrees Celsius. So in this case, because I didn't specifically say what temperature, you can leave it in Kelvin. But if I ask you for Celsius, make sure you put it in Celsius. Okay, so what kind of law did these two problems have? The relationship between volume and temperature is Charles' law.